All right, congruent and similar triangles. Congruent and similar triangles. Maybe you've seen the congruent word before. It's okay if you're like, what? Maybe you've seen similar in other contexts, but maybe you've never seen similar as referred to triangles. My job to tell you all about it today, okay? Wait, hang on. Learning goal, investigate the relationships between corresponding sides in angles in pairs of congruent and similar triangles. Now is the time in the lesson where you put away your phones and you zone in on what I'm doing. He said with 8% tone in his voice. Kids these days. Match up the following angle properties. I don't know. There's 8 terms there that I know I need this chapter. So I put them up there with some pictures and went, okay, how many of these have you seen before? It really depends. Some elementary schools are right on about this stuff and they teach you all about it. And some grade 9 teachers teach you all about it. And other times it gets glossed over a little bit. I'm not blaming those teachers. Sometimes angles gets referred to as one of the ones that's expendable compared to other things, because I can teach to you right here. Yeah. So if you know all these words, or if somebody else knows all these words, good. If you don't know these words and you're learning them right here, well, that's fine too. Let's look at the words. Alternate angles, interior angles, isosceles triangle, complementary angles, opposite angles, supplementary angles, co-interior angles, and corresponding angles. Actually, some of these names work pretty well where even if you haven't seen them before, you might look and go, I think I know which one you're talking about there. Does anyone want to take a shot at any of these here and match up with the picture which one it's talking about there? There's at least 2 really easy ones. The first one is E. She says those are opposite angles. Yeah, even if you didn't know that going in, if you just look at that picture and go, yes, AA, BB, those things are matching up. So if you just write in there, opposite angles. So I just repeat it there. Even if you didn't know that coming in, hopefully it's like, yeah, that one's opposite angles. Makes sense. They're opposite.
Second one, C.
The second one, C, he says, oh yeah, this is the one I thought was the easiest. I hope most people have seen the word isosceles triangle before. But take a look at what it says, because maybe you never thought about this before. Stop that. Isosceles triangle. The angles opposite the equal sides of an isosceles triangle are equal. This one makes perfect sense to me when I think about it. I go, if that side is the same length as that side, then the angle's opening up into them. It's like an alligator's mouth. If your alligator and my alligator both open up into the same size, they must have the same angle that they've opened up, you know? If the alligators are the same size, you know. Okay. Hopefully you get what I'm saying there. Okay, that's good. I think there's at least one more that I think is not too bad. The second one in the last row.
No, sorry, second row, the last one.
Second row, the last one.
No, second.
Second row, last one. This one is B. Yes, interior angles. And again, that's another one that even if you didn't see it today, you're like, yeah, the inside angle is a triangle. Have you seen that before, that the angles in a triangle always add up to 180? So it's sort of a shocking result, really. But it is true that all triangles in 2D, yeah, if we're on a curved surface. No, I got a riddle for you in just a second. Interior angles in a triangle, the sum adds up to 180. Very handy. We ask you a lot of questions where we give you 2 of the angles, you got to find the third. Ready for my riddle? A bear, listen carefully to what the bear does. A bear walks 5 kilometers south, then 5 kilometers east, then 5 kilometers north, and ends up right back where he started. What color is the bear?
Brown. Black.
It is not brown. Let me go over it again. The bear starts at home. He goes 5 kilometers south. Then he goes 5 kilometers east. Then he goes 5 kilometers north. What color is the bear?
White, because he's at the poles.
He has to be at the North Pole. That's the only place you can do that exact trick. Yeah? Imagine on a globe, if you went north, sorry, south, then east, then north. That triangle's weird, isn't it? It's a very curved triangle at the North Pole there. It's curved at the top of the pole there. Yeah. Maybe you need a globe. Yeah, you can go, if you on a globe you go straight south, then straight east, then straight north, you'd end up right back at the North Pole. Yeah. Yeah. It's a good riddle. What color is the bear? White. It must be a polar bear. No brown bears hanging around at the pole. Yeah. They wouldn't last too long. They wouldn't last long. As tough as they are, they wouldn't last too long. Sounds like good. Good joke. Can we get back to the math, please? Okay, go. Which one? Middle one here. Course. She's right. You've seen these before, or you're just looking at them and figuring them out? Yeah, she's seen them before. These are corresponding. And I didn't have enough room to write on the two lines there, so I wrote it underneath here. But this diagram should be marked. Yes? It's not marked there. The F is there to show you its corresponding angles. But what I mean is this angle, and I'm going to mark a little X, and this angle are the same. Those corresponding ones inside the F. That makes sense to me. If those two lines are parallel, then the line should meet them at the same angle if it's a straight line. I grew up in the country, and we had roads like this that went at an angle. I think the only one in Brantford is Charing Cross over on King George Road there. You know, it comes in on an angle. It doesn't meet straight up. It comes in at an angle. And what this is saying is, if you're coming in at an angle at roads that are parallel, every time you get to a road, you're going to meet it at the same angle. That makes sense to me if it's parallel. You got another one? This one here? Co-interior. Yeah, you know what? That would look like co-interior to me. That could match up with that. But that's not called co-interior. It has a different name when they add up to 90 like that. Yeah? Is that supplementary? Okay, yeah, this is the one I was worried about because the words complementary and supplementary, we don't use them very often. And the words themselves don't obviously attach. You know, like interior was like, okay, I get what that one is. So the two I thought I was going to have to give you were, this one's supplementary when they add to 180. And this one's complementary when they add to 90. And it's totally okay even if you saw that you didn't remember, because we don't really, complementary angles, yes? Because we don't see that all the time. We don't use those words all the time. So even if you saw them, you might not have remembered them. Yeah? What are we down to? 2? And what words have we used? Now this is a strategy I hope they're teaching you in your classes that have a lot of matching, you know, religion, English. These type of courses use a lot of matching type questions. But I hope they're using the strategy like, well, why don't we cross off the ones we've used? We used opposite. We used isosceles. We used there. We used interior. Do we use corresponding? Yes, we used corresponding. Do we use alternate? No, we didn't use alternate. Complementary we used. So now we got alternate and co-interior. Now let me help a little bit. I'm going to mark the angles I'm talking about. In the Z pattern, the ones inside there are the same. In the C pattern, the ones inside there are supplementary. They're not the same. The C pattern, they're not the same. What do you like? The C is alternate. And this one is co-interior. That's the weirdest name on the list, I think, is the co-interior. But they're inside the C, so they're co-interior. Yeah, I don't. If you don't like that, me neither. Some of the words I like, and some of the words are like, oh, that's going to be a little bit difficult to remember. But you've got your reference page now. And because this chapter only has an assignment, this reference page becomes very important because you can flip back and go, what's that called again? Yeah? Okay. Well, I hope that brings back some memories. But here, I say what's left of the lesson. Half of it is so ridiculously easy, you'll wonder how it's in grade 10. And the other half is just a little bit more difficult, okay? So if you find this next part pretty easy, it's okay. I've got a little tougher stuff coming. Congruent triangles, a pair of triangles that have equal corresponding angles and equal corresponding side lengths are called congruent triangles. Congruent means equal. They're the same triangle. Not that interesting, I must tell you, mathematically. If they're exactly the same, what do we care? The only thing we'll care about is making sure that they are equal. Maybe we don't have all the information. So, for example, triangle ABC is congruent to triangle DEF. Everything's the same. Now watch me get confused, and then you bail me out, okay? If everything's the same, they must have all angles the same. I can see. See, both have 100 degrees. That looks like they're the same. Yeah, I'm feeling good. Then the bottom corner here is 25. 25, this one doesn't say 25. But it is 25. How do you know it's 25? Oh, yes, but just looking at, you're right. You're so right. This question does say it's congruent, so I would know it's 25. But if I didn't know for sure, let's say I was trying to decide if this was congruent, how would you know? They have to add to 180 anyways. And actually, I think I would build that skill in now. See a triangle the rest of your life and they give you two angles? Don't even read the question. Just get organized here. And this angle here is 180. Subtract the 55. Subtract the 100. It's 25. That's got to be true about the triangle. And over here, the same thing. 180. Subtract the 100. Subtract the 25. And I get 55. And now I'm feeling a lot better about the fact that this thing's congruent because it's got all the same angles. But he's right. It said it was congruent, which means if this is 9.5 and that's 8, what's DF? It's got to be 8 as well. It's just reflecting my mood. I'm a little blue today. You'll be all right, Mr. Todd. All right. Think about, oh yeah, long way. I didn't remember till this morning. Can you believe that? I got this morning and went, oh, I got a lot to do. Well, how am I going to do this? I'm like, wait a minute. Long weekend coming up. So good. So what's the third side in this one then? Has to be 4 centimeters. Okay, so that's the nice thing about congruent triangles, is that they're just all the same. And once you've established they're all the same, there's not much to talk about. The most I could do is maybe flip the other triangle on its side or something like that and make you sort of think sideways. But okay, we have a new symbol for congruency. We won't have to write is congruent. We have this symbol. Mathematicians decide that equals should be reserved for numbers. And so if we're talking about triangles, we better have a different symbol for equals. And this is the equal symbol for triangles. It means the triangles are congruent. Because equals is not the same as congruent exactly. Equals is like these two things are the same number. Equal congruent means they're the same triangle. Thus, we can write the congruency statement like this. We can instead write triangle ABC. We don't have to write the whole sentence. We can just write equals with a little squiggle on top. Those two angles are congruent. I'm almost done talking about congruent triangles, by the way, because there's not a whole lot to talk about. If they're the same, there isn't a lot of discussion that has to happen here. What's that? Yeah, I also have to talk about similar triangles. I'm almost done with congruent. That's why I said the next part of the lesson has two sections. One that's, I think, pretty easy. And then another section that's like, a little bit more. Let's go. Example. Given that triangle ABC is congruent to triangle XYZ, they're telling me right off the top, these are the same triangle. It says, find all the missing measures. I hope you don't need me for this. Take a minute, look back and forth carefully at the two triangles. There you go. Are you done? I hope so. Hope so. You're done? I hope he's kidding. I hope he's kidding. How long is YZ? Look at, I'm starting to use the, this is what's going to come up is the ability to just, what's that? It's 5.2. Because they're congruent. How about AB? 6 centimeters, because they're congruent. I like congruent triangles, you say. This is nice. Yeah, I know. We don't spend much time on this. And then the last angle, Over here, this one's got to be 30. And this one's got to be 60. The 90 was in both already, so we already was given that. I'm not saying congruent's always that easy. Maybe they'll give you a little less information, and you got to look at the triangle and sort of go, ooh, where is this? But it's pretty close to that easy every time, yeah? Similar triangles. There, if you've fallen asleep, it's time to wake back up because similar triangles can be a little bit tricky. We're not going to go too far with them, so it won't get that tricky here, but these can get a little bit tricky. Similar triangles. Actually, let me do a different demo for a second, and I'll show you a great idea to think about what similar triangles are all about. Here's what I'm going to do. I'm going to use my active board to make a triangle. It's tall and thin. It might be isosceles, but that's not the point of what I'm going to do. Okay? Now I'm going to take my active board and watch what I do. I'm going to take a picture of that thing. Math tools. Where's it? Camera. Area snapshot. And I'm just going to take a little picture of this. Oops. Tools, camera, area snapshot. Get a picture. There it is. Copied. Same triangle. Right now, they're congruent. But watch this. Now I'm going to make them similar. Similar. Whole similarity lesson coming in like 2 seconds. You ready? Angles are still the same, but not the sides. Yeah? So it's the same triangle, but it's been blown up or reduced. I do this on photocopying all the time on your tests and stuff like that. Maybe I blow a triangle up or make it smaller or bigger. Yeah, same triangle. Yes? One other thing I need to tell you, though, let's say I decided that I took this thing, and this side was 9, and now this side is 3. That is, I made it 3 times smaller. That's going to happen to all the sides. So now if I said that was 9 and this is 6, you should be able to figure out what that bottom side is. You're dividing by 3s, so this would be a 2. There's the whole idea of similar triangles right there. There's lots of details coming, but that's the basic idea of what a similar triangle is all about. All right, good. You're happy? We go back. Similar triangles, a pair of triangles that have equal corresponding angles. The angles will still be all the same, but the sides won't be the same, but they will be proportionate. Fancy word. That means what I said. If you're tripling, everybody's tripling. If you're doubling, everybody's doubling. Where's it going to get hard? Ooh, maybe the multiplier is like 2.8 or something like that. That might make it a little more difficult. Yeah, divide by 2.8 or multiply by 2.8 if you're going to the bigger one. Absolutely. So that's, as I promised, it's a little harder than congruent, but let's not get too carried away. Be warned, though, similar triangles can get a little difficult as the shapes get complicated. We do a calculus question with spheres and with cylinders, and there's triangles in each one, and trying to decide which ones are similar. And it can get a little bit going. Ours won't get crazy like that, but be aware. When that happens in later grades, be aware that I warned you. Similar triangles can get a little bit tricky. Okay, this question says, for example, triangle ABC is similar to XYZ. Wait, I thought it said all the angles are the same. I don't even have all the angles. Yeah, she says it's 40. Yeah, stop messing around, Ms. Todd. You can just go 180 minus 60 minus 80. And that was part of the grade 8 and grade 9, which was getting that third angle. And it seemed like no big deal. And it is no big deal. But now we're going to use it. So this angle C is 180. Minus 60 minus 80 is 40. And now I know that that other triangle has a 40 in there. Not because, for 2 reasons. One, they told me it was similar, so they must have all the same angles. But also I could go over here and go 80 and 60 is 140, subtract 40, or subtract from 180, I get 40 there as well. Now, are we sure that the sides worked out to be proportionate? If the angles are all the same, it's going to. There's a little trick about similar triangles. If the angles are all the same, you already know they're going to be proportionate. But let's make sure it worked out. What's the multiplier here? 1.5, yeah, because what you can do is go, well, 9 divided by 6. And me personally, I always go bigger divided by smaller, because then I get a number that I can look at and go, there's the multiplier, 1.5. It works with smaller divided by bigger, but that's not the way I do it. But if I divide corresponding sides for all of them, I get 1.5 every time. I must warn you, if things have been rounded off, or if you measure it with your ruler, things could be off by 0.1, because if we're not measuring it perfectly, then we might not get perfect answers. So I don't want you to think that it's not true because you measure one and it misses by just a little bit. Rulers aren't perfect. Yeah, they don't get right down to all the decimals. So we represent similarity using this symbol. Instead of the equals, we just do 2 swirls. We go, these things are kind of equal, aren't they? They're kind of the same triangle, but they're not exactly the same triangle. So we use 2 of those swirls. But actually, sometimes I see textbooks that use a single swirl. Okay, so be prepared for a single swirl or a double swirl. Then we can write similarity statements like this. Triangle ABC is similar to triangle XYZ. What's that? What happened? Why is there what? Oh, I don't know. Somebody was having fun making the notes like, oh, we'll make it colored. It's not colored on yours, is it? But we did use different symbols. We got a sun, a filled-in dot, an open circle. Actually, for angles, you'll see all sorts of different symbols people use. As long as you use the same symbol in both, you're just talking about the angle. Okay, how are we doing here? Slide 5 of 9 on mine. So we're getting into the second half of this. Okay, so 2 ways the triangle can be similar. If either of these things are true, the other one will also be true. Okay? So you got 2 ways to go at this depending on the information. If all the angles are the same, they are similar. Done. Each angle would be the same. Or if the ratios of the side lengths, that's what I did here. Look at, I did all 3 ratios here. If all 3 ratios come out to be the same, they're similar, and then you know the angles are the same. So there actually is a little help here. You could go with a triangle and decide that all angles are the same and use that to multiply to get the sides. Or you could check all the sides, find out it's similar, and then you know all the angles are equal. So there is a few problems you can do with this, depending on what information I give you. The board, there's a sensor that is off. I got to fix it because it's sensing something's going on down here. And every time I walk by it, maybe, let's see if I can play with it over here. If I just wave my hand over here, sometimes it picks up my hand and thinks I'm touching the board. And it's like, it's a little sensitive. Yeah, I'll work on it. 3 examples doing what I just said. And using the angle stuff from the first. Because you might be like, Ms. Todd, you haven't used any of the stuff from the first part of that lesson except the angles add up to 180. Here, now I'm going to use them. Given each pair of triangles, justify that they're similar. I say ADE, so that top little triangle, and ACB, oops, that's written wrong, hang on. Little error in your note there, and it matters. That shouldn't be ACB, ABC. We got to go the same way around the triangle to say they're similar. Does that detail matter? It's going to matter. So that's a little catch there in the note there. All right, how are we going to prove these are similar? I have no side lengths. We have no angles, okay? But with no side lengths, I'm out of luck. The side length things are out. So this is all going to be about angles. There is something that at first glance you might not have noticed about the picture, though. Austin, what is it?
The parallel thing?
The parallel thing. You immediately are like, hey, once there's parallel lines, I've got a million tricks in the book. I'll do the first one. If those are parallel, then I think I'm going to use closed circle. That's what I'm going to use on my diagram to go, those 2 are the same. And here's the fancy way to say it. We do it in a fancy way so that we can get organized and know what the heck we're doing. Because when things get complicated, it's good to be organized. So here we go. Angle ADE, yes, it matters which way I go. I went from A to D to E. That angle equals angle ABC. What's the fancy word? corresponding. Those angles are corresponding. If you look at your previous note, so I can do the same thing again on the other side, and this time I'll use a little bleep, bleep, just a little arc symbol there. Not arc, Noah's Ark. Arc, A-R-C, little tiny curved section, arc. Arc, maybe you haven't seen that word before. Arc. Yeah, right, C and E. We're a little more careful than we were in maybe grade 8 or grade 9. We actually say the whole angle. So we go angle AED equals angle ACB. But you notice that the E and the C that he said angle E is equal to angle C. That just goes in the middle. We're saying that angle in the middle of those two. And that's also corresponding because we're using that F pattern. Did anyone have a teacher that you didn't have to write the fancy words? All you had to write was F pattern? Yeah, that's okay. I like what those teachers have done because the word, I'm not saying the word doesn't matter here, but the idea is like 90 times more important than the word. The idea that if you've got two parallel lines, those angles in there have got to be the same. Well, I'm almost home. I've showed two of the angles are the same. Watch this one. Angle DAE equals angle BAC because they're the same angle. Yeah? We call that common. They're common to both. Therefore, all angles are the same. Therefore, triangle ADE is similar to triangle ABC. It told me that at the start, but then it asked me to justify it, to prove it was true. And the parallel lines were extremely helpful in all that. But maybe, if you have seen this before, your teacher might have said, due to angle, angle, angle similarity. They might have used a triple A symbol there, and that's great if you want to use those. I'm not getting too hung up on those. But yes, those things are out there, and they make things a little easier to write. Do you have any questions about that one? I'm going to do an example that's extremely similar. It's extremely similar. Oh, a little eye roll. I saw someone give me the full-on eye roll. That was good. I enjoyed that. Listen, I have 4 children. The eye roll just makes me laugh. I enjoy that. I'm used to telling stupid jokes and getting the eye roll. The full-on, that was good. They were like, their head sort of rolled with their eyes. You know when you roll your eyes so hard your head goes too? You're like, oh, yeah. You know who you are. I saw it. Don't like stupid jokes? Okay, here comes another stupid joke. I'll do part B for you, and I won't charge you any money for it. It'll be a freebie.
No, but we already paid you though.
Did I already do that joke?
Yeah.
Oh, all right. See, it made me unhappy that you remember that joke.
Mr. Cobb, is that purple or blue?
To me, it was blue. Did you think it was purple?
That was purple. That was purple.
All right.
That was purple.
Give him the eye roll. All right. Triangle PQR is equal to triangle STR. Is it the right way around this time? PQR. No, it's not. Oh, yes, it is. Sorry, it is the right way around this time, yeah. Can we prove it's true? Again, the parallel lines bail us out. Oh, yeah. Let's start with opposite. That's not the one I would have started with. But I think you're right that opposite's the easiest one. So I'm going to put a dot here and a dot there. You don't have to use dots. You can use arcs. You can use double arcs. And I'll do that in a second. I'll use some arcs and double arcs so you can see those. Here I go. Angle PRQ equals, oh, I don't like where I put that. Just a second. Angle PRQ equals angle TRS, and she says they're opposite. That's a nice, easy one. Okay? Now we need somebody who is capable of turning their head and their head sideways without passing out there. Yeah, maybe easy when it's on a page like that, right? You just turn it sideways, and so now you can see the Z pattern, hopefully. Where is it? P and T are the same. I'm going to use arc, okay? Arc, arc. Oops. Arc. Yes? Angle QPR equals angle STR. And do you have the fancy word? Alternate. This is why we needed the fancy words, to do the fancy proofs. And then finally, I'm going to use double arc because I think it's in the homework. I think that's true that you see double arc sometimes, so I want to use it here. Double arc, which maybe would have helped Noah if he had a double arc, eh? That would have been angle PQR equals angle TSR. Q is S, yes. Actually, there's two different reasons you could give here. That third angle, sometimes you're like, I got it two different ways. What two ways could we use? Alternate angles is one. But there's another reason. Once two angles are the same, the third one's got to be the same because the triangles got to both add up to 180. So sum of angles. Look at this crazy sentence. Sum of angles theorem. Yee. No. Have you seen this? SATT? That's the way geometry people write that. Sum of angles of triangle theorem. No, we get to know it so well we give it a short form. SATT. Yeah. Okay. So it was true two ways. Oh, and then therefore. Triangle PQR, similar triangle STR. You have questions? Nuh-uh. Is it okay? We do one more. That was getting the angles all the same, two different ways. And there could be other questions in the homework that ask you to do different angle theorems depending on the nature of the diagram. Yeah? But it all come down to this. How can I prove all three angles are the same? Yeah? Or no angles whatsoever. What's the other weapon? Find those ratios. Yeah, find those ratios of the sides. So, largest over largest is the way to go. If these, that's a little hint for your homework. If they take the triangle and they take this triangle and they flip it over and sideways to try to mesh you up, just match them up large to large, medium to medium, small to small. Okay? So the largest sides are RT over JL is 18 over 6, which is 3. So if these are similar, the multiplier must have been 3. Then the medium sides, ST over KL, 15 over 5, which is 3. Starting to look like they're similar. Got to check the last one, though. Check the smallest sides. RS over JK. JK. 12 over 4 equals 3. Every side got multiplied by 3. I'm going to make the Kahuni statements, but I'm going to tell you something that's important. Therefore, triangle RST, similar to triangle JKL, as the ratios of the sides are all the same. Actually, there's one more thing that might come up because of that. It's not a big deal. But once you've made that conclusion, you can go back to your diagram and go, oh, that means those angles are the same. These angles must be the same. And these angles must be the same. Okay? So one leads to the other. If you find out the corresponding sides are all proportional, you know the angles are the same. If you find out the angles are the same, you know the corresponding sides are proportional. And we're going to use that as we go through the chapter to go, with different evidence and different amounts of information, we can figure out a lot more stuff.
Is there any way to find the angles?
Yes, next chapter. See, you guys right now, the triangles you can solve are right-angled triangles. You can do Pythagorean theorem, and if I give you two angles, you can find the third. I'm going to give you a lot more weapons.
But what if we had no angles?
If you have no angle, no, I got something. I've got something coming that can find one of these, find any of these angles. I can get them before the next chapter's out. Not the that's confusing right now, right? We're starting Unit 7 today. Chapter 8 will go, yes, any triangle, as long as you give me at least a side and an angle or another side or angle, is very little information, we can work it out. Yeah, really, truly. It's going to be awesome. And not too difficult, too. Sounds like, oh, that sounds hard. Not really. Trig isn't known in grade 10 as the toughest chapter. Like most people are like, I like trig. Grade 11, well, things get rough. But we won't spend a lot of time talking about grade 11 now. Let's just focus on finishing our grade 10 year. Okay? Assign work 3, 7, 8, 1 to 5, 9, 10. When are you going to do that? You could do it right now. If you feel great about the test for tomorrow, done. If not, you're going to switch now and do test prep. And you can do this on the weekend, any old time, right? So.